So we have to continue. Number 3A, we are asked to, using the R6 below, the question says we should draw the decision boundary for the model function of x equals to the beta x raised to power t with parameter of the beta equals to 1 and 1. You can see it here. And also t equals to 2.5. So we can plot the line that represents the equations. This is the line that represents the equation. The decision boundary is the line that separates two classes or region in the future space. Points on one side of the decision boundary are predicted as one class. The points on the other side are predicted as the other side. So what we do is to let the plot decision boundary determine the predicted label for x equals to 2 and 1. This power t is given in the question. So in this plot, the axis, x-axis are represented and the y-axis represented. So the x-axis represented as x1 and y-axis represented as x2. The decision boundary is the line that separates the plus region from the negative region. So to determine the predicted label from x, this and this, 2 and 1, we can evaluate the point location relative to the decision boundary. So for x equals to 2 and 1, when we substitute the value into this equation, this is what we are going to have. We substitute which value? Substitute the beta value into this equation. We substitute it here, this is what we are going to have. So at the end of the day, the value give us 0.5. So since the function of x is greater than 0, the point x is the what? Is the positive side of the decision boundary. Therefore, the predicted label y would be positive because why? Because the function of f is greater than 0. If the function of f is less than 0, that means that the boundary decision is going to give us minus. So note the plot is simplified representation of the decision boundary and may not accurately reflect the scale and precision disposition of the decision boundary. It's meant to provide a general visualization concept. So this is just the assumption behind that. Thank you.